So we've got a second order linear differential equation here. Y double prime is equals secant squared of x, and these are our conditions. So at pi over 4, the value of y of x equals 2, and the derivative at pi over 4 is also 2. So curious conditions there. Let's see what happens. Now I said that this is a linear differential equation, second order. So this secant squared of x, that doesn't make it non-linear. The secant squared x is not our value of our y of x. That's not what we're looking at here. If we had y double prime squared of x, that will make it non-linear. But we're not going to look at that today. We'll look at that in another video. Okay. Now, first of all, let's get y of x. That's our goal. So what we need to do here first is take the integral with regards to x on both sides. So if we've got the integral of y double prime dx, that should equal the integral of secant squared of x dx. Okay, let's integrate both sides. Well, y double prime will just give us y prime. I won't put a constant of integration in there yet. I'm going to put it on to this side. So now the integral of secant squared of x, that's a famous integral. That's going to give me tangent of x. So that's tangent of x, and constant of integration, as I said, I'm now going to put plus c. Okay, now we can jump in here straight away because y prime pi over 4 equals 2. Well, we've got our y prime here, so let's look at that. So y pi over 4 first derivative equals 2. So therefore my y prime at pi over 4 equals 2 equals tangent of x plus c. So this is the bit I'm actually looking for when I try and solve for my c. That's our goal. We want to find this c. So pi over 4, that's our x. So now I can rewrite this as 2 equals tangent of pi over 4 plus c. Well, tangent of pi over 4, we know that that just equals 1. So now I've got 2 equals 1 plus c. So therefore my c equals 1. So straight away I can progress to that stage. Okay, now let's take the integral of this to try and find my y. So now I've got the integral of y prime with regards to x is my integral of tangent x plus c, which is plus 1. And then integrate that with regards to x. Okay, well this one here, the fundamental theorem of calculus, that will tell me that that's my y of x. So I can just put that straight in there like that. No cost of integration. I'm going to do it on the right hand side like I did here. So this one here will give me negative natural log cosine of x. Now, as I'm dealing with natural log, to try and keep my domain as wide as possible, I'm going to give this an absolute value, and then plus 1, integrate that with regards to x, just gives me x. And then I need another constant of integration. So I've used a c already, so now I'm going to use d. So don't fall into the trap of putting c twice. Okay, so this is now what's called my general solution. But we have some conditions for this function that we can use. So y of pi over 4 equals 2. We've already used the derivative to give us our c from here. So now let's use this one to find our d. Okay, so y of pi over 4 equals 2. So that equals minus natural log. I'm actually going to put my x first. I don't like to put my minus sign straight after my equal sign. So I'm just going to write that as x minus natural log of cosine pi over 4 plus d. Okay, let's put my absolute value in there. Now all this here, as I did here on this calculation, I'm just going to set all of this to equal 2 and just solve for my d. So here my x here, I can write pi over 4 because that's what I do when I see an x. So I've got 2 equals pi over 4 minus natural log of cosine of pi over 4. Now that will just become the natural log, and now I've got cosine of pi over 4. Cosine of pi over 4 is 1 over root 2. So that's 1 over square root of 2. So I'll leave that as an absolute value. Now I know that there is a positive, but I'm just going to leave it like that for now. Next line we will deal with that. And then plus d. Okay, now I'm well on the way now to isolating my d. So I'm going to leave my d over here. So I'm going to write that here. And now working backwards with these, I'm going to bring all these onto the other side. My 2 is already here, so that will stay there. I've got a minus pi over 4 when I bring that over. So let's work like this. Minus pi over 4, so that's an add 2. And then natural log of 1 over square root of 2. I'll now add that. So the natural log of 1 over square root of 2. And I just put that as a bracketed term because I don't need the absolute value because I know that's a positive value. Okay, so now we're well on the way to getting our d isolated. So now log of 1 over root 2. What can we do with that? Well, when we have a fraction, we could turn that into a minus and then write the square root of 2 on the top, take the reciprocal basically. So now I've got, rewriting this, put my 2 first. I've got my minus pi over 4. And now I'm going to flip this inside our logarithm. And now I've got logarithm of square root of 2. Okay, now that is set to equal d. Now the log of square root of 2, let's just have a look at that here. Natural log of square root of 2, that's the same as saying the natural log of 2 to the half. 2 to the half is square root of 2. So now I can say that's natural log of 2. Bring this half out front, just write that like that. So that would be the same when I'm solving for my d. So let's put my d up here now. So d equals 2 minus pi over 4. And then minus natural log of square root of 2 is just a half of log of 2. And the sign, don't forget, here is the minus. So minus natural log of 2 over 2. So that's my d. So let's take this off the board and then plug all that into my general solution. Okay, so my c, I've already put that into my equation so far. I just now need to add my d. So now my final solution will be y of x equals, now let's write my d first. I like my 2 to go first. I've got positive numbers straight after the equal sign. So 2 minus pi over 4 minus natural log of 2 over 2 plus x. And then this thing here still comes down into my final answer. So minus the natural log, absolute value, cosine of x. Just be careful with all of those brackets. Okay, so this, with those conditions, that is my final answer. Okay.